than the define phase, of course. Okay, so we finished the define phase. Again, they're define, measure, analyze, improve, and control. So now let's say we're done, we have completed the define phase. Now we go to the measure phase. And the measure phase is to establish baseline performance, basically. You want to know what is my performance now. I defined that I have a problem. Now I get approval from my management to be working in this project. Now I'm going to go to the define phase. So I measure my baseline, my current performance, basically. And again, here, this is the sub process, is the developer process measurement. Basically, how to measure the problem. How am I going to measure this problem? When and where the data come from. I need to check the quality of the data. And again, this is a good map. There are a number of tools. All you need is go and complete basically these tools. Go complete the first tools, the second tool, third tools, and so on and so forth, and then just complete them. And we're going to go through these tools now step by step. I know that this is a lot of information to be given in 3 days. Normally, especially, you know, each day is only like 3 hours or less than 3 hours. Normally in a Greenbelt, some people, when I took it in Aramco, we took it in 2 weeks, okay? And so you're gonna have to be doing a lot of efforts yourself, okay? But the concepts are not difficult, and especially if you break them into tools, and each tool you take it and you try to understand it, and you need to be working in projects, because if your target is something higher than just a green belt, if you want to go to black belt, yes, you can do it through an examination, but master black belts, you have to demonstrate that you have actually completed real projects, and you need to be spending 3 years as a black belt, full-time black belt, to be able to apply for a master black belt. But all of these tools, if you have the passion for it, if any one of you, I'm very sure will be able to get them just fine. So again, in the measure phase, there are tools, and we're just going to take tool one by one. And then that's basically the flow of it. It's how to measure the problem, when and where to come the data come from, how do we ensure the data quality, how to establish the current behavior, what's the current performance, and so on. Because this is what measuring the problem is. You need to take data and you need to measure it. You need to look at it and see where your current your current performance is, where your baseline performance is. So the first tool, which I'm sure everybody have heard of it, is key performance indicators, KPIs. So KPIs basically are a measure that reflect the process of performance. How is the process is performing? It's a reflection. It's not necessarily exactly, because some people are good in tweaking these KPIs, and that shouldn't be the purpose of KPIs. And where do you get KPIs from? You get them from the CTQs, the critical to quality trees that they did. It's basically the CTQ specs from the CTQ tree. Remember this tree? That's, we came up to a CTQ specs specifications. We said to be able to satisfy our customers, we've seen the voice of the customers, and we know that he wants us, for example, let's say, my mouse is not moving, we want to provide 24/7 phone-free fault reporting number, for example. We want all faults to be fixed within 4 hours. That's a CTQ specification. So we're coming to this. So each one of these, we're bringing them down here. We say call answer within 7 rings. That's a CTQ specification. We want an update within 30 minutes. We want all faults to be fixed within 4 hours. we want 1 visit maximum to access customer site, and we want no occurrence of fault within 90 days. So these are specific, critical to quality specification. So now, how do we transform this into a KPI? Then what do we do with this? We say, okay, a customer-driven KPI is, for this particular one, is the number of calls answered within 7 rings. So that's our KPI. How many, how many times do we actually answer within 7 rings? And so on, percentage updates of available within 30 minutes and so on. Also, you need, while you're doing this exercise, you need to know the data that you need to be able to calculate your KPI. For example, for this one here, what you want to measure the time taken to answer each call. And maybe nowadays with electronic networking and so on, this data is probably automatically there. So or you can configure your system to collect these data. So this is where you get the data from, and so on. So this is what your KPIs normally need to be taken not from anywhere. Okay, need to be taken from your customers. After you interviewed your customer, you heard your customer, you heard the voice of your customer basically, and then you translated his voice into a specific or CTQ specifications, and based on this you built your KPIs. There are some lean measures, which I think maybe for the sake of time, I'll go over them very quick. But you can actually derive your KPIs from your voice of customer, or there are some lean measures that any process, they apply to any process. You have a process and you want to calculate these lean measures or these lean KPIs, and you can use them as a way to watch or monitor your performance. So if you have a process like this process, step 1, step 2, step 3, step 4, this is basically a processing time that it takes to complete a step 4, and this is the processing time to complete step 3, and so on. And between each step and another, there is a queue time, which is just the waiting time. So from this information, you will be able to calculate your lean measure. And also you have a completion rate, how much you're completing, each product. This product can be a manufacturing product, a class or whatever, or if it's in a training institute, then this may be how many students I'm finishing, or well, if it's a hospital, how many patients am I completing, and per day or per hour or something like this. So this is your completion rate. Your process cycle efficiency is basically the total value add time divided by the total lead time. This whole thing is called a lead time from here to here. From the time, let's say if it's a hospital, from the time the patient gets into the hospital or the clinic to the time he gets out of the clinic, okay? Or if it's in the laboratory, or if it's an X-rays, and from the time it comes, the problem comes to me, or until I finish it, this is called a lead time. These process steps, some of them are value adding, and some of them are not value adding. And value adding, you can tell. You go to the hospital as a patient, and you can see what is value adding to you and what's not value adding to you. Taking too long time to put me in the system and telling me to wait or whatever, this is all non-value adding time. Or waiting for approval for the insurance to come and so on. So this is not all value add time. So what you want to do, if you want to gauge your process cycle efficiency, you calculate all the total value add time and you divide it by the total time, and you get basically, it's a percentage, it's a PCE percentage. The average lead time is basically the work in process divided by the completion rate. So how many patients do I have in my hospital now? And what's my completion rate? If in my plate I have 16 patients, and I'm finishing one every hour, then I will, then I will only be finishing 16. So that's the way you calculate it. So this is the average lead time, and there is the takt time, which is the available work time divided by the customer demand. So these are one thing also is the operational definition. Operational definitions are developed to provide a clear and unambiguous description of a KPI. You establish a KPI, you want to make it as clear as you can. So you want to put a good operational definition, and here is some operational definition diagram. For example, this is you want this to be in millimeter, I don't know, maybe let's say 10 millimeter or 15 millimeter. If you just describe it in words, it's not going to be easy. But if you put a diagram with it, then it will show very, just as you say, one picture is worth 1,000 words. If you're talking about not acceptable to see a dent in the can, maybe what you need to do is just put a picture of it and this. Or if it's this is the fault fixed how many times, then you just want to see. You take the process, what happens, and each time there's a fault, you go back to the systems. So this KPI is measured based on how many returns there is from the system to the system. So just to make things clearer. So this is called an operational definition diagram. Now, an important thing is the data words. Once you collect the data, you need to classify your data into basically 3 data words. Are they continuous data? Are they count data? Or are they attribute data? Because it depends on the sort of data you are going to deal with them slightly differently. So this is very important. But before we do this, we go into the data words. Let's do review some statistics, just to be all in the same line. I know that some of you, those who already took the yellow belt, I know some of you haven't taken the yellow belt before, or this is the first time. But those who have taken the yellow belt, maybe we went over this, but we're going to go fast on this anyway, and it's a good refresher anyway. So statistics, back to statistics, back to grade 8. Is it grade 8, grade 9, whatever, ثاني متوسط, ثالث متوسط. So basically there are 2 measures. There's a measure of central tendency. Where is your average, your median, the center of your point, where is it? This is called central tendency, okay? And one of them is the mean. The mean is the average. So what's the average? The average, basically, if you have data points like this one, all you need to calculate the average is you add them up together and you divide by how many points. That's the average. The average, I think everybody knows what the average is. Take the data points and divide by. Okay. Another measure of central tendency or measure of location is the mode. The mode is basically the most common data point in your data. What's the number that is recurring all the time? So for example, in this example here, you see that 119 is the most common data point in this. So this is called mode, and in Arabic it's called manual, I guess. The median is basically you take your data, and this is only basic statistics, but it's good to review it. You take your data, you sort your data from the smallest to the largest, or the largest to the smallest, it doesn't matter. And you take the middle point. The middle point is your median. This is where the middle of your data is. If they're odd number, let's say nine data points, 1, 2, 3, 4, 9 data points, then you put 4 to the right, 4 to the left, and you take the middle one. If it's an even number, then you just take the average of the middle 2. So why do we sometimes use the median? And I think that's example, maybe I gave it before. is when you go, for example, in a city, or listen, not a city, maybe in a rural area, and the houses there are all, I don't know, maybe 500,000 real, 600,000 real, maybe $1 million or something like this. But in the middle of this town, there is a big palace, an expensive palace for one rich person there. So if you actually take the value, and let's say it's 30 million, 40 million, if you take this data and you take the average, the whole average, and you include this data point among, then this is going to shift the data somewhere. Say, how much does the cost, the cost of whatever, the prices of houses in this area, if you take this data point and you calculate the average, you're gonna see that the average goes up. But if you do the median is just going to give you the middle data point, basically, or the average of the middle data point. There are other measures of location, like the quartile. The quartile, you look at the median divide the data into two sets, basically, here and there. The quartiles divide it into 4. So basically, this is the middle, which is the median or second quartile, if you're going to measure it. And this is the first quartile, and this is the third quartile. Basically, you just you divide your data into 4 sets, and this is where your first quartile, second quartile. And by the way, no, let's go to this one. Now there is also the percentile. Percentile is, again, the median divides into 2, quartile divides into 4, percentile divides into 100. So what's the 25th percentile? 25th percentile is the same as the first quartile. The 50th percentile is your median or your second quartile, and the 75th percentile is the same as your third quartile or your third quartile. So these are all what we said are measure of central tendency or measure of locations. Now there are another sets of statistics which are called measures of dispersion. Measure of dispersion, basically how the data are actually basically varying around the mean or something. So the measure of dispersion, the first one is the range. The range is basically the maximum data point minus the minimum value. So in this case, it's 21, 24 minus 114. You get that's called the range. The range, it ranges between this data point to this data point. You have the variance, and the variance is this is the way it is calculated. You take the average, and then you take each data point, and you see how far is it, the distance between it and between the mean, and basically you take the average distance between each data point and the mean. But because when you subtract values that are less than the mean, you will get a negative number, and when you subtract values that are more than the mean, you get positive values. So for them not to cancel each other, you take the square of it. The square is always positive. So that's and then you don't divide by all the data points. You subtract one, and that's a very deep statistics. I'm not gonna go into this, but has to do with degrees of freedom and so on. So basically, if your average is 120, you take the first data point minus 120 square, then the second data point minus 120 square, and so on, and then you divide by n minus 1, which is 8, and you get your variance. And this is a measure of how scattered are you around the mean. That's what the variance is. The standard deviation is nothing but the square root of the variance. Because we're taking the square all the time, now we're taking the square root of the square to go back to standard deviation. And for whoever asked about what the standard deviation is, this is how you calculate standard deviation. This is one way to calculate a standard deviation, but the easier way to calculate a standard deviation is to use your calculator, and even easier if you have an Excel. You know, just put your data in Excel, okay, and just ask it to give you STDEF, and it will give you standard deviation, will give you variance, will give you mean, give you all these things. But it's good to understand the concept before you actually get into the tools. This is very important. Another statistics which is important and sometimes tricky to understand, but it is important because everything is really based on it. It's a standard error of the mean. And this has to do with the sample size. If I take data points by themselves, the scatterness might be high. But if I take a sample, I take 5 each time or 10 each time, and I take the average of that sample, then the average will actually be at a different level. As maybe a good example is throwing the dice. Anybody knows the dice? A nerd has six things, six faces basically. 1, 2, 6. If you throw each time only 1 at a time, then your data will be between 1 and 6. But if you throw 5 nerds each time, 5 dices each time, then their average is not going to, it's very rare, unlikely that you'll get all of them 6s. So you'll never get an average of 6. You'll get, if you average them up, you'll get an average of 4, 3.5, and so on and so forth. But you'll never get 6. You'll never get them all 6 or get them all 1. Only in rare chances. So your dispersion is not the same as when you throw them one by one. If you throw them in a group, like I throw 5 at a time or 10 at a time, then my dispersion will be smaller. And this is important because normally when we check our processes, we take a sample. We don't just take one data point. We take a sample group of data point, and we take the mean of them and we plot it as one data point. So we need to adjust in this. We take our standard deviation and we divide it by the square root of the sample size. If there are 10 pieces, then it's 10. Like in this case, we take the average, 3.34, we divide it by square root of 8. Again, these are all concepts. It's good to understand. It's good to review them back and so on. But at the end, it's just like when we teach you in the 4th grade how to divide. The long division. The purpose of it is not to actually use it like this. The importance of it is to understand the concept only. Because at the end, you're going to take your calculator and you're going to use your calculator. You're not going to divide manually. You're not going to do many things. You're not going to do them manually. But here it's important to establish an understanding of how it works. Because if you use it as a black box, which you could use it as a black box, you will not appreciate the importance of it. You'll not understand what's behind it. So it's important. Just like when you say multiplication, you could use a calculator to multiply, but the more you know what it means to multiply, what it means to divide, division, it means like this, multiplication, the meaning of it is this. It's very important. But that's. Again, there's also measure standard error proportion, and this is the way it is calculated. I'll just skip this slide. Here are some exercises normally that we do in face-to-face classes, but for the sake of time, I think we're gonna skip them. Again, this is an important issue. When you take a class face-to-face with an extended period of time, and we take each one of these and we do exercises, the concepts get drilled better into the brain. But again, you know, if you spend some time in it, it shouldn't be difficult. Okay. Now it's time to talk a little bit about the normal distribution in statistics. It's also called the Gaussian distribution. Okay. And this normal distribution, as we described it before, you take your data. Most of your data will be within -1 sigma and +1 sigma from your mean. So 68% of your data will be here. If you go 2 sigma, 2 standard deviation away, or 2 standard errors, depends on if you have a sample, then most of your data will actually be 95% of your data will be between -2 and +2 standard deviation. And in practice, the normal distribution never ends. To give you an example to understand this a little bit better, if we go to a classroom, okay, and you take their ages, for example, or if you go to a group of people and you take their weights, their sizes, their whatever, okay, you'll see that most of the people are within a certain range. So you go to college, for example, you see the majority are between 21 and 20, maybe 18 and 23 years old. So, and that all depends on standard. You take their averages, you take their standard deviation, and you can be sure, confident, and I can say, well, I'm sure that 68% of my students are actually between this age and this age. 1 standard deviation before and 1 standard deviation after. I can even be 95% sure, more confident, that my average age will be between -2 standard deviation plus 2 standard deviation. So just you take these data and you can, it's all about risk. The whole thing, the whole methodology is about risk, and it's about confidence in what you're saying. Saying, I'm confident that the people here are between this age and this age. How do I calculate them? I calculate the mean, I calculate the standard deviation, and based on this, I will be able to say that most of them are within 1 standard deviation, 95% are. If I go to 3 standard deviation, then 99.73 will actually be between these 2 data. So that's what. So in theory, normal distribution never ends. It will go forever. But in practice, most of the results will fall between -3 sigma and +3 sigma from the mean. Normal distribution in practice. How do we use this in practice? And I think for the sake of time, I'm going to skip this. So after this introduction about statistics, let's go back to the data word overview. We said our data is either continuous, it's either count, or it's either attribute. What do we mean by continuous data? Continuous data is when you're measuring something, and basically when you're dealing with averages and variation. So this is a continuous data. These numbers here that you see are actually continuous data. Why? Because they're continuous. There's always a finer point of them. Let's say somebody's height is 195 or 170 centimeter. Is it 170? Somebody can be 170.1. Somebody can be a little bit higher, 170.12, and so on. Because this data, there's always some data between them. So this is called continuous data. And this could represent an example, for example, the time to fill a new job, temperature is a continuous data, pressure in PSI, the diameter, and so on. And for this kind of data, the statistical model for it, when you model it, when you want to model it, you use a normal distribution here. And for a graphical tool, you use a histogram, and the statistics that you're going to be using for these data, you either calculate the average, the median, the standard deviation. So these are basically the data that you will be using for this. So that's what continuous data is. This is what a histogram is. Basically, you take the data and you break them into intervals. You say the people from age 1 to 2, how many do I have? Ages from 2 to 3, how many? Ages from, and so on. So this is your category, and this is the frequency of each category. And as you can see, this looks like at the end it will actually be a normal distribution. That's how you actually do a histogram. If you're going to do a histogram, you just take the data from 0 to 1. I have 20 of them. From 1 to 2 minutes or hour, I have 6 of them. From 2 to 3 hours, I have 5 of them. And you just calculate these, and you calculate their relative frequency. Their relative frequency basically is this number divided by this number. It's like 20 out of 45, which is like half of them, or 44%, are actually within this range. So you calculate your histogram, and then you plot your histogram. So that's continuous data. That's continuous data. Now for count data is a little bit different. Not a little bit different. It's actually different than continuous data, and it's used for counting things. And again, why do we care about continuous data and count data and so on? We want to measure our performance. So here in this case, we want to see how many defects, for example. Okay, example data will be 1, 2, 3, like the second set of data, 45, 37, 39, and so on. All of these are called count data. And they could represent how many errors there is in one invoice, if you're talking about invoice, how many calls to clinic receptions, how many scratches on sheets of glasses, if that's a defect, how many applicants for a vacant job. All of these are counts. The statistical model that you use is not a standard deviation. What you're going to be using is a Poisson distribution. And the graphical tool for it is again histogram, but the statistics that we will be using is not mean median anymore. It's going to be defect per unit. How many defect per unit? Because it's count, we're counting actually. How many errors, or the average error per invoice, average number of applicant per job. So these are basically the statistics that we use for count data. Now, how to spot count data? It's very easy. In count data, there are no half units. And if I'm counting men or women in this room, okay, then I can say there are 2.5 men. That's just count as a count. While height and weight, you could always say kilo, 2 kilos, no, 2.5 kilos, or 2.25 kilos, or 2 kilos. You know, continuous data, you can actually divide them further and further and finer and finer. But count data, they're actually count. You just count. Basically, for count data, there's no upper limit. 0 is possible. You could have a 0, and count it per specific area of opportunity. Normally, this is what defect per unit is you know, you have an invoice, for example, and there are 10 opportunity for making mistakes. So you want to see how many out of this 10. So it's usually count per opportunity. You have a trainee that is graduating from your college. How many opportunity for defects? He may not have mastered this or this or this or this. So you're going to count them, the skills, and see how many skills have he actually not mastered out of total of this many skills, and so on. But it's just a way to measure. So we finished with the continuous word. We're finished with the count word. And then there is the attribute data word. And the attribute data word is basically either yes, no, good, bad, pass, fail, but that's what it is, either one or the other. It's called attribute data. And it could represent computer inspection results, on-time delivery, part availability, and so on. And all of these are important whenever you're going through improvement project. Don't think that you can actually achieve improvement without going and taking data and looking at the data, analyzing the data, and so on and so forth. What's the statistical model for attribute data? It's a binomial distribution. Presentation tool. What you use here is summarized attribute data, and the statistics used is either summarized, normally percentages. Just say what's the percentage of fail, and what's the percentage of pass, or what's the percentage of yes, and what's the percentage of no. So that's basically the statistics. The average, the mean, the median, the mode, and things like this, they don't apply anymore. So these are 3 data words that you need to be understanding, that you need to know what they are, to be able, now when you collect the data to measure your performance, you want to see how am I going to measure my performance? What sort of data do I need? And when I have this data, how am I going to model them? How am I going to look at them? How am I going to present them to my management? Yes, I agree, it looks maybe overwhelming now, because it's a lot of data, except maybe for industrial and system engineers and so on, because they've already studied this anyway. But it's actually, if you take it piece by piece, just one tool at a time, you try to grab it, you try to grab the overall infrastructure of it, and you take each one of it, and you try to it's not more difficult than statics. It's not more difficult than dynamics. And I'm sure it's not more difficult than the drilling course. And I'm sure it's not absolutely not more difficult than orthodontics calculations and things like this. That's an absolute fact. So when we compare the data words, continuous and count versus attribute, the continuous not as simple to understand as attribute. At the end, when you say yes or no, it's easier than when you go to a different data. But the continuous data and count word, actually both continuous and count. Continuous is even better than count. They're richer and they're easier to analyze. And they provide more resolutions into your data. Yes, they are more costly probably to collect, but and I'm not sure if they're really more costly, because it all depends on the sample size. Sometimes it can be even less costly. Why? Because you didn't need this much data to be able to analyze a continuous data. You didn't need this much data point. While if you go to count data word, you're going to need a lot of points to be able to make a call in the thing, to make a conclusion. But you could always convert, what am I going to say? Convert count to continuous. Convert attribute into continuous or count, okay? Because count and continuous and count are better. So how do you do that? So you do that by simple things. Say, instead of asking your customer if they are satisfied or not satisfied, are you satisfied? Are you not satisfied? This is an attribute, yes or no, okay? No, change your question to make a grade from 1 to 10. From a scale of 1 to 10, how satisfied are you? So you're already changing, you're getting a richer data than yes and no. You're taking a scale here. Or instead of recording if the delivery is on time or not on time, okay? So maybe you want to take a different approach. Just measure exactly how early or how late it was there. So this is a continuous data. If you're in a car cleaning service, for example, it says the car is clean or not clean. go and record the number of bits of dirt. It's still there. Okay, well, I found 5 or 10 or whatever. So this is a count. So you're actually changing from attribute to change and so on. This is another comparison of the data word. You have a continuous data word, count data word, and that's just this is how they look. This is histogram with upper specification. Again, in the count word, you have a histogram with upper specification, but in the attribute data, you just have how many good parts and how many bad parts, and basically you do it in percentages. This is again a quick summary. If it's continuous, then this is the distribution that you will be using. This is the statistical model, okay? And this is the common statistics, the mean, average, and so on. And these are some useful graphics. So this chart summarizes it up, and it can come in handy sometimes. For the data collection methods, now you decided what sort of data you want. You decided your KPI. You know what sort of data you want. Now, how am I going to collect this data? So you want to make a decision now. Am I going to collect from existing or from new data? Because new data can be expensive, but sometimes if you just say, oh, because I don't have the data, then I'm not going to take it, then you may not be able to solve the problem. So you need to first compare existing data with operational definition. You have an operational definition that we completed. Go and compare your existing data. If the existing data is satisfactory, good. We don't need to collect new data. We have existing data. We're just going to use the existing data. But if the existing data is not satisfactory, then you have to actually go and collect data. Two key types of data collection, either in a process where the data is integrated in the process and you didn't actually do it manually. There's a process and you just integrated part of the process. You can, especially in computerized world nowadays, many of the data you can actually just set up your system and data will be collected automatically. Or if not, then you're going to have to do it manual. But that's going to be an extra cost and extra burden and so on. And so you just need to evaluate your options. Now, data collection plans and sampling. If you can take 100% of the data, ooh, this is ideal, the best. Take all the data? Yeah, take all, you know. But most of the time, you can't actually take all the data. So you're going to have to rely on samples. You just take a sample. If I want to take the average age of the whole school, I can't go to the whole school. I don't know, maybe I can, maybe this is not the best example. But if I have a big, I don't know, pile of things, then maybe if I take random sample of this pile, then I will be able to make a good conclusion out of it. So do we measure 100% or take a sample? The answer, if readily available, then why not? If it comes at a cost, then check the cost effectiveness, basically. But to make any conclusion, you take a pile of things and then you want to make a conclusion about their weight, about their height, about their whatever, then you need to take a minimum sample size. You need to take. You can't take one and say, okay, I'm taking this. I'm going to take one. I'm going to measure it, and it represents the whole thing. No. Normally there is a minimum sample size, and also there is a minimum sampling frequency. You can't take it every morning, every day, because in the morning may be different than at night, maybe different shifts, maybe different things. So the frequency also, so there's a sampling size and there is a sampling frequency. For the sample size, this is a way to calculate the sample size. Basically what you do, you take the range, okay? Let's say the range takes from 20 to 30 days, that's a range. You take this range and you assume that there are 6 standard deviation within this range. So if it's from 10 to 30, so that's 20 days, that's the range. It's between 10, so there is 20, between 10 and 30. You divide this by 6, you get to 3 or 4, تجبره فوق to 4. And you use this formula basically here, which is this formula here. So 2 times the standard deviation, and the standard deviation we get it from the range by dividing the range divided by 6, and then you divide by the precision, which there is normally a required precision. Like if you're taking my weight, for example, I say, okay, I want my weight, but with an accuracy of 1 kilogram, half kilogram, whatever. In this case here, maybe I want the accuracy, but within, I don't want it to be the accuracy within 1 day, 2 days. That's the accuracy or the precision, better word for it. So you just plug it in this formula and you calculate 16. So what you need as a sample size, your sample size has to be a 16 data point. So you take 16 data point, and from this 16 data points, you can be confident that this 16 data points, if they are random, of course, then they are representing they call it the whole population, basically, the sample and the population. So you take in, this represent the population. There is another one similar for the attribute. I'm not gonna go through it. And to be honest, exams are not there, but my purpose here is not really exams. My purpose is that I want at least to tell you that there is a tool that you can use. If you have attribute data, then there is the same thing. There is a method, and it's only a mathematical formula, and it's very easy to use, and it will tell you. But the reason why I'm presenting this slide, look here. Here you need 16 data points only as a size to make a conclusions about population, about your population. All you need is just take 16 data points, and you're fine. But if you're not using continuous, you're using attribute data, which is yes or no, then this number can actually go to 1600. So sometimes it's probably more cost effective. Why to be confident in my data, I need to take 1600 data points if they are attribute data, yes, no, or true, false, and so on. While if I take continuous data, all I need is 16 data points. So sometimes it can be more cost effective, and all you need is just, instead of saying delivered in time, not delivered in time, tell me the data. It was 15 days, it was 14 days, it was whatever, 2 days. These data are much richer. So if you can have them, then do that. It's better to actually take continuous or count data than just to measure your system with attribute data. Here is an exercise. I'll just take 30 seconds for you to grasp it. Normally, I would give it for you to solve. But let's say your invoices have taken anywhere from 30 to 60 days. And you want to make a conclusion after it, basically, and then you want to know how many data points, what's the minimum sample size that I need to collect. If I want to get my results within plus or minus 3 days, precisions, basically, or accuracy, is a precision. So what do we do here? First of all, we calculate the range. The range is from 30 to 60. So that's 30 days. And then I divide by 6. We said there are 6 standard deviations within each, within a range. So basically here is 60 minus 30. And let's see it here. So 60 minus 30 divided by 6. So I can estimate my standard deviation to be 5. And now this is a given, it's a 3 days precision. And all I need is just to plug into this formula, nothing more, nothing less. So I go 2 times standard deviation, which is 5, divided by 2, which is given in the formula. No, precision, which is in this case a 3. It should be 3. Sorry. Okay, or maybe this one should be 3. Where did we go? This one is a 2. This one is a 2 actually, and this one is a 2. And all we're doing here, we're just plugging into this formula, and we're getting the minimum sample size to be 25 data points. So that's the minimum sample size. That's how much I need to actually make a good conclusion about the time taken to process an invoice, basically. If you're working in data and debt collection and things like this, محصل ديون يعني. So that's the sample frequency. If we go to the sample size, sorry, that's the sample size. If we go to the sample frequency, then the sample frequency, what you need is you need to take 4 times every process cycle. Yani if process, for example, 3 shifts, then your process cycle is 8 hours. If people are working 3 shifts, so in 24 hours, there are 8 hours. So in this 8 hours, you need to take at least 4 times. You need to take the data 4 times. So you need every 2 hours to take data. Yes, please, as a question, or is it somebody unmuting? Perfect. So there is a third data word.
Excuse me, doctor.
Yes.
Why you divided the range by 6 in the previous example?
Well, that's just a quick way of calculating the standard deviation from the range.
So 6 is standard or depend on the...
you know, people have found, statisticians have found, okay, that the relationship between the range and the standard deviation is a factor of 6. So you take the range, you divide by 6, you find the standard deviation. This is a quick way of doing it. If you have the standard deviation, then just use the standard deviation.
Okay, thank you, doctor.
Okay, I hope that's clear. Okay. So we said there are 3 data words: the continuous, the count, and the attribute. But there is a 4th data word, which is basically when you collect data, you need to collect other data with it. You know, for example, I'm collecting the height. Well, I collect the height, then I have to put names against these heights. I say Muhammad's height is this much, Fatma's height, and so on and so forth. So I need to collect. Like in this case here, you say the location, maybe the priority. There were low priority, medium priority, high. These are data that actually complement contextual data, they call it. This is just to complement your table. You're not going to put a table with numbers without basically naming these or categorizing these data. So these are called contextual data. So that's the 4th data word. Basically, when you collect data, you need to collect other information. I collected these data in the morning, or I collected them in the afternoon, or these are low priority, or these high priority. This sort of data is called, I'm very sorry, the 4th data word, or the contextual data. ممتاز. Because without contextual data, we will have basically trouble looking for clues and data and so on. So we need to. Let me see. I think maybe this is a good stopping point for tonight. I will be happy to entertain a few questions. I think I've already lost my voice, so for tonight. I think my family will be happy, so I'll stop talking from now. I won't bother them anymore. I'll go to sleep right away. So, any question, please? I'm sorry, you know, normally in face-to-face with a longer time, this thing runs better. We normally give more examples. but I think you know, you're all at least bachelor degree graduates. So some of you are master PhDs, some of you are professors. So this is you can pick it up. You know, all of this is just an introductory and a taster for the thing. But I will be very happy to entertain maybe few questions. Please ask questions.
First of all, thank you very much, Doctor. There is one slide when we got the number of samples, we calculate 16 samples.
Yeah.
Remember this one?
This one?
Yes, this one.
Yeah.
Okay. Can you just give us a brief how we calculated?
Yeah. Okay. So let's read the example again. Collecting data to assess the lead time of an invoice. We're just taking data to see the time it takes an invoice to be processed. Okay. And this time can be anything: to fill up a job, to fill up water, to whatever. It's time at the end to service somebody at the clinic or whatever. So this is the range. We've seen it that it takes from 10 days to 30 days. So this is the range of the data. The range is actually from 10 to 30. What is this range from 10 to 30? That's 20 days, right? Because 30 minus 10 is the range, is like we said, is the maximum minus the minimum. So the range is 20 days. If you divide this 20 days by 6, because this is the relationship between range and standard deviation, you divide this by 6, you get to 333 something, or 366 or something. The closest even number for it is 4. 3.6, you didn't use 3.6, you just sum it up to 4. So you use the number 4 here. And the rest is just a plug-in in the formula. So it's 2 times the standard deviation. So you calculated your standard deviation to be 4. So 2 times 4 divided by 2. 2 is the precision. Precision meaning how wrong would you accept the data to be? Say, okay, if you're wrong by 2 days, then that's fine. Okay, so that's what the precision means. So you divide it by 2 here, and that's what the precision is. And 2 times 4, that's 8, divided by 2, that's 4, squared, that's 16. Is this clearer?
Yes, thank you very much, Doctor.
I can be confusing sometimes, you know.
We appreciate that. Thank you very much.
Thank you very much. Thank you. Yes, any more questions? What do you think in general? Am I going too fast? Am I going too slow? You think this material should be covered in 2 weeks, or it can be all covered in half an hour? You know, am I slow pace, fast pace? Am I clear in my language? Some people accuse me of having a strong Arabic accent, but I am an Arab. What can I do anyway?
In general, it's very good. But the slide that we are crossing, is it important for us in the exam, for example, or in the future?
Well, as I said at the beginning, I know that some people thought maybe I was taking too long, but to succeed in Six Sigma, not necessarily in the exam, okay? To succeed in Six Sigma in general, these concepts are very, 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 very important. Is this going to be included in the exam? Maybe not. Most likely, these details, maybe not, you know. Usually the exam is more general than these things. But my intention, honestly, here is not, I know you want to pass the exam, and it's all your right, everybody, to pass an exam. But honestly, my intention is that there's a good tool here that actually will improve the organizations that you're working for. The exam, you will pass it anyway. I mean, exams are exams. You study for it, you will pass it. But it's what's important is the material that you will learn, because this is what you will be actually taking away with you. The certificate is, you know, I don't know, but it's much less important than the information that you get. I hope that answered the question.
Yeah, the important to change our mentality, our way of thinking, right?
That's what I said at the beginning. You're gonna be failing big time if you're just thinking, because the same thing, if you focus on KPI only, just improve, because this is how some businesses are. They just want to focus on KPI. We just want to look good. It doesn't matter if you're good from the inside. We just want to look good. That's you're not gonna go anywhere. That's I rest my point here. Any other comment, questions? Dr. Fayyaz, would you like to add anything? Dr. Suleiman, Khalid, our guest of honors, anything you would like to add?
Assalamu alaikum warahmatullahi wabarakatuh. Really appreciate your commitment to give us your best till you lost your voice.
Thank you very much. Thank you. Thank you.
Yes. Probably I may want to add an example with relation to sampling.
Yes.
An example would be like, you cannot exactly say there are how many diabetic patients in Saudi Arabia. So you choose a sample population on which you do a study, and you make a projection that this is the percentage of diabetes in Saudi Arabia. Absolutely.
By the way, Dr. Fayyad Sayed is a professor at Imam Abdul Rahman University at College of Dentistry. We actually learn from the people like these people. We don't teach them.
We learn a lot.
Especially in the medical sector, they're into research and statistics and publications and so on. But they're very good. Thank you, Dr. Fayyaz, for coming.
Thank you.
Yes, if you allow me, Doctor, I would just like to thank you for the comprehensive introductory. I think there was a lot of information today, and yet there is another to go, another more 2 days to go, and we are really sorry for you losing your voice.
No, that's fine. I'll get it up. Don't worry.
Yeah. I think from my perspective, the scientific example, it's very important even for those who like to practice it after the course, just to put an issue or a problem and try to scoop it out to see how the outcomes. I've tried it myself with the QMS, and the result was very promising. That's in general, but thanks a lot, Doctor.
Absolutely. Look, if you don't practice it, you lose it. Simple as this. And the best way to practice it is to work in projects. And the best way to work in projects is to go to your management and convince them. Go find yourself a slot in their communication meeting, okay, and make a presentation. Go and define a few problems from, if you can, and say, this is how much the problem is costing us, and then go and present it. And if you get their support, this is how things will actually, this is the start of learning. This is the journey starts right there. That's because that's the way you learn, when you work on real problem. And I will be very happy, especially for the define phase. Anybody who'd come up with the define, like the problem, the charter, the problem charter, basically statement. Go and finish that part and show it to me, and then I'll critique it, for you. But again, remember, this is an improvement initiative. It's not really a training initiative per se. Okay, so an improvement initiative, normally Six Sigma is an improvement initiative. This is why you train people at yellow belt and at green belt, and because everybody takes a role in this improvement initiative. So your best bet is that, and eventually you will be able to, to do it, and anybody will be able to do it. Go and define a few problems, and go present them to your management and try to get things. If you're the manager or it's a problem within your management, or if it's a personal problem, then yeah, you can do it yourself. But that's how you learn. You actually need to work on real problems. There are other things that we will be covering tomorrow, like design of experiments and things like this. That's probably good for, I think, even for Dr. Suleiman and Dr. Fayyad, for maybe it's a pure technical issue, the way you deal like in laboratories and things. This might be good. They're not managerial per se, they're pure technical. But again, the way to improve or the way to learn the subject is to actually complete real projects. And I hope that everybody will have the opportunity to complete a project. Even if it's one project, go to your management and say, this is what I'm working, and get their support, because you need their support. Any other issue, any other thing? All right, if no further question, then thank you very much for tonight. We'll see you tomorrow night at the same time. I might have to create another invitation from Zoom. I think so. I'll send it to you all. I'll send you a copy of this presentation. Not a copy, actually. I'll send you a link to access this presentation, and it will be there. So that's it, basically. If there is no further questions, then we'll call it for tonight. And sleep tight. Good night. And anything? Any question? Anything? Any addition?
Thank you, Doctor. Thank you. Good night.
Good night. Good night. Good night, everybody.
Thank you. Thank you, Doctor.
Thank you so much.
Thank you very much.